So the Great Southern Reef is an extensive chain of rocky reefs that run virtually from Kalbarri and south along the south coast of Australia, around Tasmania, up north to almost about Brisbane. So it straddles the entire southern coastline of the continent. One reason is that we all live pretty close to the reef, so about 70% of the Australians live within 50 kilometers of the Great Southern Reef. And it's sort of in our backyard, so we take it for granted. The other key reason, I think, is that until recently hasn't had an identity, partly because it is scattered across the entire coastline. It's managed differently by all of the different states, and that is in contrast to, for instance, the Great Barrier Reef, which for 50 or 60 or more years has had a massive international identity. There's been multiple National Geographic programs on it, and David Attenborough's been there God knows how many times and that sort of thing. So if you look at the media coverage around reefs in Australia, for instance, 80 to 100% of the media coverage, even in states like Tasmania that are thousands of kilometers away from the Great Barrier Reef, is about corals and Great Barrier Reef and not about temperate reefs and kelp forests. So that particular study is a study that tries to look into the future, where we over the past 5-10 years or so have done a lot of research on trying to understand what has happened until now. So we had a big marine heat wave about in 2011, and that had some massive consequences for the temperate ecosystems. And we spent a lot of effort trying to understand those impacts, but that study that we now have published was an attempt to then try and look into the future. We got all of the herbarium records that exist in Australia for temperate seaweeds, and we sort of mapped them out and then looked at the environmental conditions that they have been found under sort of in the past couple of decades. And it turns out that there's a very, very strong relationship between the presence of different species and the ocean temperature. Now, we know that climate change, one of the major things that are happening with climate change is that the ocean's getting warmer, just like the atmosphere. So there's some quite good projections of how warm and the ocean will be in different places at different time scales and under different carbon emission scenarios. So we use those strong relationships with the presence and absence of these seaweeds to look into the future from some of these climate projections. And it looks like, if these models are to be believed, and there's a lot of reasons why I think we can believe them as crude estimates at least, it looks like there will be very substantial changes to the current distribution of these big habitat forming seaweeds that are basically the biological engine of the Great Southern Reef, if you will. On average about 70% of the current distribution, but the range is somewhere between 30 and 100%. So there's some species that we will lose entirely from the Australian continent, and some species that will only disappear from the east coast and the west coast and be pushed down onto the south coast. Possibly the most widespread big seaweed across Australasia is Eclonia radiata, the common kelp. It's one of those species that will only reduce its range by about 40% because it's currently found all the way up to, well, it used to be found all the way up to Kalbarri, but after the heat wave got pushed back about 100 kilometers. But it's one of those species that is currently found sort of quite far up the east and west coast and all the way around the south coast. Now that's going to get pushed down onto the south coast and only be found around Tasmania and some pockets on the south coast. That's one of the species that will do better. I think, well, not better than it is now, but the better out of all of the lot. And then there's another species such as the giant kelp, Macrocystis parifera, which you would have seen footage of in California, for instance, really big, tall one. That will get pushed entirely off the Australian continent and will not be anymore in Australia. I think there's a lot of reasons why Western Australia, and indeed the world needs to be concerned about this. If we start with the global picture, the Great Southern Reef is one of the most biodiverse temperate marine ecosystems in the world. It has one of the highest rates of species endemicity of any temperate marine ecosystem in the world. So a lot of the species that are found here are only found here on the Great Southern Reef. And we're talking anywhere between 30 and 80% of the species within certain groups of animals and plants that are only found here. So if you look at the seaweeds, for instance, it's the most species-rich area for seaweeds in the world. We have something like 1,000 species of seaweeds on the Great Southern Reef, and about 80% of them, at least in some classes, are only found on the Great Southern Reef. So if we lose those from the Great Southern Reef, we lose it from the planet, basically. In an Australian context, sort of more regionally, the Great Southern Reef provides a very broad range of ecosystem services to Australia and Australians. And these are things such as supporting two of our most valuable fisheries, so the fishery for abalone and the fishery for western rock lobster and southern rock lobster. And it's things like supporting tourism, even in some areas, local areas, places like Philo Island, where you have the little penguin and things like that, that basically feed off things that live on the Great Southern Reef. Those reef-related activities around tourism and things like that represent something like 15% of the total regional economy. These are very, very crude calculations that we've done, but all up the Great Southern Reef contributes in the order of $10 billion per year to the Australian economy in direct ecosystem services. There's a lot of ecosystem services we have no idea what the value is, things like nutrient storage and carbon dynamics and things like that. And if you compare that number, $10 billion per year for the Great Southern Reef, and contrast that with the Great Barrier Reef, the number is 2 to 3 times larger. So the Great Barrier Reef contributes about $5 billion per year. In the local context is that we have a couple of fisheries here that have been impacted by the loss of seaweeds, large seaweeds. Historically in fisheries management, there's also been a lot of focus on processes that take place other places than on the reef. So for instance, the rock lobster has a pelagic larval phase, and it's the flow of the Lewin Current, which is basically sort of more offshore oceanographic processes, has a very large impact on the rock lobster fishery as well. And I think historically there's been a lot of focus on those types of dynamics because they have been very instrumental in determining the yield of the fishery, how many larvae were delivered and things like that, because that was where the major sort of limitations were historically. That's changing, and I know for a fact that fishermen are greatly concerned about the habitat changes. We currently have a couple of research projects that are in very close collaboration with the rock lobster fishing industry that's specifically designed to look at the role of habitat and habitat change with these seaweeds and the links to the fishery catches. That's the $1 million question, I guess, or several $1 billion question. There's no way of saying anything certain about that. I think what can be said with certainty is that we absolutely need to do something. We need to treat the cause, not just the symptoms. It's also quite certain that the reef will change. We're already committed to something in the area of 2 degrees warming, regardless of how much we reduce our greenhouse gas emissions now. But it will get a lot worse if we don't do something drastic. So whether 30% is enough, who knows? It is going to change the way it is now. The reef in 100 years' time will be very different to what it is today. That's quite certain right now. And there's no serious scientist that actually questions whether global warming is real. It's a little bit debate about how much of it is caused by humans and how much of it is caused by natural variation, but it's beyond any serious questioning that humans have contributed to the current global warming.